Hi, my name is Tony Chen. I'm an electrical engineering student currently studying at the University of Michigan at Ann Arbor. Thanks to the SURE program, over the past 12 weeks, I had the opportunity to work under Professor Anthony Grbic on his wireless power transfer project. So why wireless power transfer? Look at this awful mess over here in this picture. Can't imagine myself trying to unplug an electronic device from this mess. So imagine all of these power cords being eliminated. Imagine one day you can just carry your laptop, walk into a Starbucks, and don't have to carry this huge and heavy power adapter with you at all. Now, wouldn't that be awesome? Those are some of the applications that my research project was trying to strive for. As I just mentioned, wireless power transfer can be used to charge your laptop, other consumer electronics, etc. It can also be used to charge electric vehicles, which is under development right now in many companies. People are trying to create this charging pad in the road that could charge electric vehicles atop. Some other applications of wireless power transfer include providing power for industrial tools and military devices. I wanted to show a picture over here which shows an experiment that we had set up in a laboratory. It is shown in the bottom left on this slide over here. This loop over here is transferring power wirelessly to this loop over here. And as you can see, it is able to power up this light bulb here. And what's so cool about this is that this light bulb is not connected to an outlet at all. Right now, I'm going to talk about what I've done over the past 12 weeks. First, I had to work on trying to model our wireless power transfer system using something that electrical engineers are really familiar with, circuits. I had to use Agilent's advanced design system to simulate how efficient our system is at various distances. ADS is a software that is the industry leader in high-frequency circuit design. In the end, I had the opportunity to perform experiments and take data. Our results show that we could achieve approximately 50% power transfer at approximately 35 centimeters. It doesn't sound like a huge distance, but compared to the size of these loops over here, it is relatively big. So in the last 2 weeks of my research program, I started to use ANSOS HFSS, which is another high-frequency design package used in the industry to design a printed circuit board. Some of the benefits of a printed circuit board include it is easy to mass produce and it has a low cost. So one day, probably, you'll be able to buy these devices at such a low cost, and then you'll be able to power all electronics within your house. Thank you very much for watching this presentation. I hope you enjoyed it. And in the end, I would like to thank Professor Anthony Grbic, my advisor and my mentor for this whole summer, Aaron Thomas and Jason Hebel for all the help and assistance they have given me throughout the summer. Last but not least, I would also like to thank everyone in Professor Anthony Gribic's research group for all the tutoring that they have provided. Thank you again for watching this presentation. So this video over here shows an experiment that we had set up in the laboratory. As you can see, the power loop over here now is not turned on yet, but once we turn that on,
sorry, it's just a minute.
you can see that the light bulb is starting to turn on. As you can see, no power wires are connected to this loop over here at all, and then the power is just going into this loop and transferring wire wirelessly to this loop to power up this light bulb over here.